So question 6 of flow sheet 10. So in each of the following, write the function in the form y is equal to f of u and u is equal to g of x, then find dy dx. So in each of the following, write the function in the form y is equal to f of u and u is equal to g of x. Then find dy dx as a function of x. So we have A, the function y is equal to 2x plus 1 to the power 5. So to differentiate this, we use chain rule. Now, chain rule, remember how we define chain rule? We said if you are given y is equal to u to the power n, y is equal to u to the power n. To differentiate y, to find dy dx, you drop n, then you have u n minus 1. Then you multiply it by the derivative of u. You see? So now, this is telling us to use that rule here. So we let u to be 2x plus 1, like that. And then differentiate u. So we get u prime. So we have 2. Then go back and write our y as u to the power 5. So it's now a function. Y is now fu. You see? Then from there now, you find dy dx. That is 5 u power 4 multiplied by u prime. But since we already have u prime, we'll just substitute. So we have the u now is 2x plus 1, and then power 4, and the u prime is 2. So the answer is 5 times 2, we get 10, and then 2x plus 1 power 4. So let me repeat. So I was saying, we are given in the first case, we are given 2x plus 1 to the power 5. So we want to use chain rule, which says if you are given u to the power n, you need to differentiate first with respect to n. So you do the power rule and then multiply by the derivative of the u. So we have this function power 5. That function is our u. Then we differentiate u, we get 2. Then now we have y is equal to u power 5. Okay, so let's apply now the rule. So we drop 5, u power 4, and then u prime. Okay, then we come back here and say, okay, what is u? So u is 2x plus 1, 2x plus 1 power 4. U prime is 2. 5 times 2, 10. And then 2x plus 1 power 4. Like that. Okay. So your job is just to recall the properties. Ruth?
Yes, sir. I wanted to ask, It's okay even if you don't choose that formula that you gave us yesterday, the one you're saying that it's like the advanced chain rule formula.
Anyway, that's the one that we have used here anyway. Yesterday we wrote it in the form, I think we wrote it in this form. So we said dy dx is going to be du dx, I mean dy du multiplied by du dx. So du dx is like the u prime. So we first differentiate with respect to u, that's dropping the power, subtract by 1. Then you multiply by the du dx, which is the u prime. I don't know if that's fine.
Yes, thank you, sir.
So let's go to question. Yes.
Sorry, I logged in late. What's the question saying for this solution? What are we supposed to find?
So we're on question 6.
Okay.
The question says, in each of the following, can you write the function in the form y is equal to fu? Or if you find u, write it in the form u is equal to gx. And then differentiate to find dy dx. So we had the first one, it came as y equal to 2x plus 1 to the power 5. And so we let u be the inside of the power. So it can be y is equal to fu. And then on, we differentiate the u now, and then use the chain rule to the combination.
All right, thank you.
Okay. So what I expect is that you guys can follow through and be able to do the remaining pieces. So maybe so that you feel love, let's do y is equal to x squared over 8 plus x minus 1 over x to the power 4. So again, we let u be equal to x power 2 over 8 plus x minus x power minus 1. And then differentiate u. So we get 2x over 8 plus 1 minus 1 x minus 2. So that it becomes x over 4 when we divide 2 over 8 there, and then plus 1 plus x minus 2. So now we have dy dx. And since our function now has been written in the form u power 4, so when we differentiate it, it becomes 4u 3 u prime. And that is 4 u is x squared over 8 plus x minus 1 over x to the power 3. And then we multiply by u prime. What is u prime? U prime is x over 4 plus 1 over x squared. Remember that we can write how those powers and the like, you can push them up or bring them down. You can do anything with you like doing them. Okay. So this is the chain rule. So now question 7, you choose, you're not told what method to use. So you choose what you want to use. Okay. So most of it is like question 2, where there's some product, or it's like question 1, where there's some power rule, or it's like question 3, where there's some quotient, or it's like question 5 and 6, where there's some chain.
So,
Hello.
like in the exam or the test, are we supposed to show, let's say the first part where we have the 4u to the power 3 u prime, or you can just do it direct as without introducing this?
Yeah, you can do it direct. Okay. So let's go to question 8. Find the value of f of g prime at the given value of x. So f of g prime. So find the value of f of g prime. So now I want to differentiate the composite function. So what are we given? So we are taught in the case of A, we have f of u is equal to u power 5 plus 1. But u is equal to g of x, and g is equal to root x. So after we find the derivative, we must evaluate it at x is equal to 1. So we have u, so f of u is equal to u5 plus 1. U is equal to g of x, which is equal to x. So we want to find the composite function of f of g and then differentiate it. So we can choose to use chain rule or to find f of g first. So maybe let's just find f of g since we can. So what is f of g of x? So while there is u there, we substitute u. So we have root x to the power 5 plus 1. Okay. Now we can write this as x to the power half power 5 plus 1, which is x 5 over 2 plus 1. And so now we find its derivative. So f of g prime of x is going to be, we now differentiate this. So we have 5 over 2 x 5 over 2 minus 1, which is 5 over 2 x 3/2. So the first thing, we find f of g. The second thing, we differentiate the answer we found as f of g. Then now, in the derivative, where there is x, we put 1. So we have 5/2, 1, 3/2, which is equal to 5/2. Okay. So finding f of g, I mean, that's not a big deal. Just remember that after you've found it, you are also asked to substitute the value. So you can do b in a similar manner. So you substitute where there is u, you put 1/1 minus x, and then work out the function, then differentiate well. So that we go to question 9. Question 9 says, consider the curve on the xy plane given by the equation y is equal to x power 3 minus 4x plus 1. Consider this curve. A, find an equation for the line perpendicular to the tangent of this curve at the point 2,1. Now you know, a line that is perpendicular to the tangent is called the normal line. So what we are asked to find is to find the equation of the normal line. So here's what we do. So first we say, since we have y like that, then we differentiate it. So we get 3x squared minus 4. After that, we get the value. So we are doing everything at the point 2,1. So now in dy dx, we call it m when we substitute the point. 2 squared minus 4. That is 4 times 3, 12 minus 4, which is equal to 8. So this 8 is the gradient of the tangent line. The question is asking us to find the equation of the normal. Now what we know is that if you multiply the gradient of the tangent times the gradient of the normal, you get a -1. This is how the normal and the tangent are related. Now, since what we have is 8 as the gradient of the tangent, so multiply it by the gradient of the normal, which we don't know, so that we get -1. Meaning, gradient of the normal is equal to -1 over 8. Okay, so we now use the equation y minus y1 is equal to gradient of the normal, if you're looking for a normal line, x minus x1. So y minus y1 from the point, we have 1 is equal to minus 1 over 8. From the point again, we have 2, since we are doing x minus 2. So when they say a line perpendicular to the tangent, they mean the normal. If they say a line perpendicular to the normal, they mean the tangent.
Because then better for me.
Good
Because
solution.
I know.
I
If
just
things just happen, essentially, you say
Let's go to B. B says, what is the smallest slope gradient on the curve? At what point on the curve does the curve have this slope?
Sharp enough.
So what do you think is the smallest slope? What's the smallest value can this at dy dx be? So since our x is squared, the smallest number we can get here is when x is 0, which is -4. So the smallest slope is obtained at x is equal to 0. So we have m is equal to -4. At what point on the curve? So you get x is equal to 0 and substitute in the curve. So the point will be 0,1.
Sir,
Hello.
you know you've lost me. How are you getting the 0,1?
So look at the equation that we have. The equation we have, what we're talking about here, is the equation 3x squared minus 4. This is the equation that gives us the slope. So when does this become the smallest? At which point is it giving us the smallest number? Now, since x squared will always give us a positive value, it means that the lowest this can be is -4. When x is 0, because if x is 1, we get 3 minus 4, which is -1. -1 is far much bigger than -4. So we're saying, oh, okay, because of the square, this gradient, it becomes very small when x is 0. And so we substitute 0 where there's x in the gradient equation for us to get the gradient to be -4. This 0 that you have gotten, we now substitute in the original function to get the corresponding y value to make a point. We don't make a point using derivative. We make a point using the original equation.
So the x is equal to 0. We've just come up with it that we know. What am I saying? Okay, the x is equal to 0. How did we know that is the smallest slope? Or is it like that always?
You haven't understood the question. The question is saying, for what value of x? For what value of x What is the smallest slope? Gradient on the curve. At what point on the curve does the curve have this slope? If you are given a quadratic of this kind, it's the same as being told to find the minimum value. Because this gradient equation is a quadratic. It's 3x squared minus 4. So what's the minimum value? The minimum value is -4. Because this is complete. So how do we get -4? We get -4 if we make x be 0. Like that.
Okay, I've gotten it now. Thank you.
Oh, sir,
Mhm.
what if we had 3x minus 4? What value of x can we use to obtain the smallest slope?
We may not be asked to define it.
All right.
Because there it goes as you got minus infinity. The number continues becoming very small. So only those that have turning points, like the quadratic, because it can be minimum value or maximum value, those are the ones that you can be asked to find.
Sir. Sir.
Hello.
The one, was it gotten from the original equation?
Yes.
This is 0, comma.
So when you substitute 0 in the original equation, you get 1. Not so. It's -1. So this was given as an identity equation. This is the relationship between the tangent and the normal. So you use that equation whenever you're asked to find the gradient of the normal if you are given the gradient of the tangent. Or the gradient of the tangent if you are given the gradient of the normal. Okay. C says find equations for the tangents to the curve at the point where the slope of the curve is 8. So if the slope is 8, find the tangents to the curve. So if I'm told that the slope is 8, it means that dy dx is equal to 8. But dy dx is 3x squared minus 4. So it's equal to 8, meaning 3x squared is equal to 12. So if it's 12, we divide by 3, we divide by 3. So we're getting x squared is equal to 4. We root. So we have x is equal to plus or minus 2. So we have two gradients there. I mean, we have two values of x. So now we get that +2. When x is +2, we substitute it in the original function to find the y value. So we have 2 power 3. Of course, for 2, we know that 2 will give us 1. So we already have that point. So we have 2, 1. Then for -2 now, We substitute -2 there. Again, we're getting the same one. We get 1.
What about your mom for it, guys? Now I do.
So then you can find the equations. The first equation that you find, you say y minus the point 1 is equal to, the gradient is 8, so we have 8 x minus 2, or y minus 1 is equal to 8 x minus 2. So we're picking both points. So the top one, if you want, you can expand. So we have y minus 1 is equal to 8x minus 16. Down, you have y minus 1 is equal to 8x plus 16. And so you can work out those and make them look nice. Like that. Okay. That's why we leave at 1 there. So question 10 says, find the tangents of the lines to the curve at the origin and at the point 1, 2. So there you just find the gradient and then substitute the given points to find the line. And then 11 and 12, we did similar questions in, I think we brought them from the George 11 and then, where we're doing that if the slope is AB, how do you get that on the right? Otherwise, you can finish up. I think that's how calculus for the test ends. So much weight now is on the side. Since calculus has been concluded, you must be ready to stand up and say, I know calculus, and I'm ready for this test, for as long as they bring calculus. We did the graphs in the previous lessons. You must be able to say, I'll sketch any graph they ask me to. The inequalities, you should be able to solve any inequality. Trig identities, you don't need much of them. You just need maybe 2 or 3. Binomial, you're able to expand, to approximate, find the term. Find, the exponential, if it's solve the exponential equation. The log, how to solve the log equation. So nothing must be strained this far. You should be ready when T2 on Sunday. They won't go. Yeah, man.
Sir,
Um,
I don't know if you have the link to the video on binomial question 17 from the tutorial sheet.